Well, what do you think? Project X in its rebirth form. My name is Mike Copeland. I'm the project manager that was responsible for this. I work for the GM Performance Division. My team and I worked very hard to redo Project X and to continue what was a great tradition and try and make it even better. So I'll briefly cover a lot of the features that we did to this car. As you know, in 50 years, a lot's changed at General Motors. And we do things differently today than we once did. We wanted to try and incorporate a lot of the new technology and build this car the way that we would do it today instead of the way it was done 50 years ago. Starting with the frame, because that's really the basis for every car. We lifted the body, we took the original frame, electronically scanned it, and created math data for that 57 frame so that all design work could be done from that point. We incorporated C6 Corvette front suspension, including a section of the Corvette front frame rail, the Corvette front cradle, which had to be narrowed 130 millimeters, all Corvette control arms, front brakes, and all those corresponding pieces in the front. We used a steering gear, a rack and pinion power from a Chevrolet Colorado pickup truck. We used Budnick wheels on the front because they cleared they fit our design cleared. We used an 18-inch on the front to give us that more contemporary look that we would use today on a modern vehicle. In the rear of the car, we wanted to take the car to a new level of Pro Street. We wanted the car to be drivable, enjoyable, and if you've ever driven a Pro Street car, all of them are not that way. So in this car, we narrowed the rear frame rails 5 inches. We built a triangulated 4-link rear suspension for the car. It allows us to mount a Strange Engineering S60 rear differential with a 373 ratio and a limited slip. In this case, we used Budnick wheels again on the rear. They're 15 inches wide for a 20-inch diameter, wrapped in Mickey Thompson tires, just like the front. One of the things that we were able to do, because we incorporated it into math, is we put the entire suspension and all frame through what we call failure mode analysis testing. Electronically, we can go in and put loads into the chassis and determine exactly if there were any points that we can increase torsional stiffness and to look for areas to improve it. One of the things that identified for us was that 57 Chevys were inherently somewhat weak in the front suspension design. They were only ever built to hold a 7-inch wide bias ply tire and never intended for today's road loads. So we built an inner structure that attaches to the front of the car, mounts to the cowl in 3 locations, and goes forward, picks up, and 2 additional body mounts were added to the front frame to provide more structural rigidity. That in turn allowed us to move the radiator into that section, so the radiator and core support now become one piece, a part of that front structure, and when we open the hood, you'll see that it's 4 inches forward and 4 inches down from a previous production 57 Chevrolet.